Good evening and welcome to a class on geometry. We'll be looking at this topic from geometry, and I am your teacher, as you can tell, and my name is Abhijit Sarkar. Okay. And can everyone hear me loud and clear?
Yes, sir.
Okay. All right.
Yes, sir.
So without further ado, let's dive into geometry. And what I would like to do today is get into this topic called constructions, okay? Constructions of quadrilaterals. You have already seen construction of triangles, previously, probably in class 7. But today we'll be getting into how to construct quadrilaterals when certain information about quadrilaterals are given. So I thought that before we dive into the construction of quadrilaterals, it might be a good idea for me to review the properties of, some standard quadrilaterals, some special quadrilaterals, such as, parallelogram, rectangle, rhombus, and square. I mean, those are really the most important quadrilaterals that you will be seeing, in your class. Outside of that, there's also the kite, there's also trapezoid or trapezium, and we'll touch upon those. But certainly, what's most important would be for you to know, for you to be entirely familiar with the geometries of a parallelogram, of a rectangle, of a rhombus, and of a square. And when I say geometry of these figures, I mean the properties of these figures, okay? And this, so the first part of the lecture, I would be spending, by the way, before that, let me just mention that the standard textbook that I would be using would be ICSE, Understanding Mathematics, ML Agarwal. So does everyone have this book?
Sir, I have it.
Okay.
Sir, me too.
Okay, so because from time to time, I would, ask you to look up certain sections of this book and perhaps even attempt to do some problems as part of homework, if you will, like from this book. So I think it's important. It's a very well written book. Ideas are very nicely uh, explained and nice figures, a lot of nice figures. So I would strongly recommend that if you don't have this book, consider getting it. And if you have it, well and good. So basically, there's a chapter on this book which is called Understanding Shapes. And this chapter just precedes the chapter on construction of quadrilaterals. So what I would like to do is not cover the entire chapter of Understanding Shapes, but rather take sections of that chapter which I deem to be important. And the first half of the lecture would be focused on doing just that, okay? So one of the things that I like about this chapter is that, it seemingly, it encourages you to investigate, these quadrilaterals like parallelograms, rhombuses, rectangles, and squares, maybe even draw the figures and investigate for yourself, the symmetries that you see. And what do I mean when I say symmetry? I mean, similarities, equalities, parallel sides, as in parallelogram, opposite sides are parallel, equal angles, diagonals getting bisected. That's what's meant by symmetries of a figure. Okay. So what I would like to do is begin by giving you a set of guidelines. And what these guidelines would enable you to do would be that given any quadrilateral, it will enable you, these guidelines are essentially guides to investigate into the properties of such quadrilaterals, okay? Now, what I just said would be very clear, like when I take up an example and show you how this whole process works, okay? So let's think about a quadrilateral, okay? And let's draw just a random quadrilateral. Doesn't have to be a parallelogram or anything. So let's say this is a quadrilateral. So what are the various parts of a quadrilateral? Let's first talk about that. There are 4 sides, right? So the parts of a quadrilateral would be 4 sides. So when you are investigating a quadrilateral, first thing to do is ask yourself, are any of the sides equal? Are the opposite sides equal? And we know that's true for parallelograms. Are adjacent sides equal? And what do I mean by opposite versus adjacent? These two are opposite sides, these two are opposite sides, and these are adjacent sides. Okay? So the first thing to do for a quadrilateral, well, before that, so I would encourage you to draw pictures of these quadrilaterals. Okay? So take parallelogram as an example. Okay? And ask yourself, so maybe what I should do is get rid of this and put in a parallelogram in its place. And what we'll do is, I will list here things to look out for in a quadrilateral, as in a parallelogram, which will be a first example that we'll study. Okay? And these things to look out for, and there'll be a long list of it, maybe not a long list, but there'll be a list. And then what I would encourage you to do is draw diagrams of different quadrilaterals, and then do a bit of research, investigate, like where do you see equalities among sides, among angles, and then there are also diagonals, are the diagonals equal, do they bisect, and so on and so forth. Okay, so our first example is a parallelogram. So it has 4 sides. Okay, so the first question to ask would be, maybe I should write it in this way, are adjacent sides equal? So let me do this. Let me put this under the header 4 sides. So we start with the sides of a quadrilateral, and in our case, the first example is parallelogram. And we look at its 4 sides, and what questions can we ask about the 4 sides? We can ask, are adjacent sides equal? Are opposite sides equal? Okay, those are really the 2 questions, the 2 symmetries to look out for. So for a parallelogram, are adjacent sides equal? It's a question for you. Yes?
No, sir. No, sir.
No, they're not. They're not. Not in general. They could be, but not in general. Okay? Are opposite sides equal? Definitely. Okay? This is equal to this. This is equal to this. Okay? So here's another question for you. What happens if, for a parallelogram, if adjacent sides become equal? There's a special name for that parallelogram. Can anyone tell me what it is? Yes?
Rhombus.
Rhombus.
Very good. Rhombus. And square as well. Okay, but square is a special case of a rhombus. So we'll get into all of that. So one thing, after I show you what I have in mind for the moment, we will actually be able to see how these various quadrilaterals, are related to one another. Like parallelograms, rhombuses, rectangles, and squares. So I'll get to that. So that will really be our, our ultimate objective. Okay, so for now, what we'll do is we'll look at the various parts of a given quadrilateral and ask ourselves, where do we find equalities? Okay. So the first thing to look at would be the 4 sides. Are adjacent sides equal or opposite sides equal? Okay. What's the next thing to be looking at? The next thing that any quadrilateral, be it parallelogram or not, has, aside from the 4 sides, are the 4 angles, 4 interior angles, right? So as a next stage of investigation, what you need to do is ask yourself, are any of these equal? Okay, so for a parallelogram.
The opposite angles are equal.
Yes,
The opposite angles are equal.
absolutely, absolutely. So the opposite angles are equal. So this is equal to this, and this is equal to this. Okay. Then next stage of investigation. Okay. A quadrilateral is really incomplete without its diagonals. You know, the diagonals of a quadrilateral are like, quite intertwined with the idea of a quadrilateral. So next we talk about, like we investigate the diagonals, and what do we look out for is the question. So let me write that down. So any quadrilateral would have two diagonals. Okay. So after we are through with looking at the four sides and the four interior angles, we look at the two diagonals. Okay. So let me ask you, so presuming we have, two diagonals, so what are the things to look out for? Okay, what should we
Do
do?
they each other, or do they bisect each other at 90 degrees?
Right, absolutely. Do they bisect each other? But before that, we should ask ourselves, are they equal, the diagonals? Could they be equal? Are they equal? Do they bisect each other? And to incorporate the other thing that you mentioned, do they bisect each other at any special angle value, or is it just some random angle value? So do they bisect each other at angles having special values, as in, like say 90 degrees or 45 degrees, 30, 60, those good old angles that are, like very familiar to us. Okay. So these are the three things to inquire. And there's a fourth one. There's a fourth one. And it is that, anyone, like think about it. What are we missing out of? Okay. So let me pull up the diagonals. Let me pull up the diagonals. So let's first go through this. Okay. Are they equal for a parallelogram? Are they equal? They're not. Just visually, can you all hear me? Hello?
Yes.
Yeah. So for a parallelogram, are they equal? Now see, just visually, you can tell. They're not equal. This one's longer, right? And then we can actually, what we can do is we can make the difference between these two diagonals, like even larger, so that it becomes very apparent that they are not equal. So what we can do is, in order to do that, so here's what I'm going to do. I'm going to attempt to draw a parallelogram where the two diagonals look distinctly different. One would look much longer than the other one. How can I do that? How can I draw such a parallelogram? Now here's an interesting property about parallelograms. As you know, a parallelogram, there are several ways of defining it. Okay, one way is, actually the definition, there's only a standard definition. It is that a parallelogram is a quadrilateral for which both pairs of opposite sides are parallel. Okay, now it turns out that there are other ways of defining it, other criteria that would generate for you a parallelogram. And one such criteria is that the diagonals bisect. That's it. You know, if you know that for a quadrilateral, the diagonals bisect, you can conclude it's a parallelogram. Just try drawing, as I would right now. So what was my goal? My goal was to show you that the diagonals, from here it's kind of apparent, you know, like it's that this is longer than this, okay? My goal is to show you that that is definitely the case, definitely the case. So I'm going to draw an extreme case of a parallelogram where the two diagonals would appear very, very different. So what I would do is I would start by drawing the diagonals, and I would just make sure that they bisect one another. So here's how, you know, it'll go. So this is a diagonal, and let me see. So this is about the midpoint of it, and then let's say this is the other diagonal. Now if I join, so these four would be the four corners or the four vertices, what are known as vertex, plural would be vertices, or simply the four corners of a parallelogram. So now I will be joining them. Sure enough, I get a parallelogram. As I told you, this scheme would never fail, because it can be shown that if for a quadrilateral, if the diagonals bisect, it is necessarily a parallelogram. So this is a, you know, a unique way of drawing a parallelogram. You can start by drawing the diagonals. Just draw a couple of diagonals, you know, a couple of lines that bisect one another, and you join the corners. Lo and behold, you get a parallelogram. And now when you look at this figure, it's very, very apparent that the answer to this is a resounding no. They're not equal. Okay? Any questions so far?
No, sir.
Okay.
No, sir.
All right. Now the next question is about the diagonals. Do they bisect each other? Do they? Just visually?
Yes, sir.
Yes, sir, they do.
They do. They do. So this is equal to this, and this is equal to this. So they bisect each other. Do they bisect each other at angles having special values? They don't. It can be any angle. How can we convince ourselves of that? Well, by resorting to this scheme. I can start out by drawing the diagonals of a parallelogram, you know, and all I have to do is, for that, just draw a couple of intersecting lines that bisect one another at any angle that I choose for it to be. Okay, so here this angle could be anything, you know, so this angle at which, so okay, so this is the midpoint of this line segment, and I wish to draw another line through it, okay, such that actually another line segment through this midpoint, so that even this line segment gets bisected at that point, and I can choose the angle to be anything. I can choose the angle to be anything. Okay, I can make the angle between them. I can make one of them really small. I would get a parallelogram. I can choose to make the angle, you know, say bigger than that. I would get another parallelogram. Okay. They don't look, this doesn't look too much like a parallelogram because, you know, it was an, because I didn't, obviously it's, you know, the picture is a little off, but you get the idea. So the answer to this is again no, but this is a yes. Do they bisect each other? Yes. Now there's a fourth thing that we are missing that we need to investigate. Once we draw the diagonals, okay, after we draw the diagonals, sure, we need to investigate these three, and then there's a fourth thing to investigate. What could it be? What are we missing out of? Look at this picture. What are we missing out of? So we have covered the four sides, okay, in our search for equalities and so on and so forth. We have covered the four sides. We have covered the two diagonals, okay. We have, we have covered the four sides. We have covered the four interior angles. We have covered the two diagonals, okay, to check to see if they are of equal length, if they bisect, are they oriented at a special angle value, and then there's just one more thing that we need to check out.
Sir,
What is
whether if the diagonals bisect the angles.
Yes, very good. Do the diagonals bisect the corner angles, the four interior angles? Absolutely right. Do they bisect the corner angles? So what do you think for a parallelogram? When you draw this diagonal, are these angles getting bisected? What do you think?
No, sir.
I'm sorry, could you repeat yourself?
No, sir.
No, sir. Okay, so is there any yes response? Does anyone think that they do? Okay, good, good. That is correct. They don't bisect each other. How can I convince myself? Well, from here, it's kind of apparent. But again, just like I convinced yourself that I can, the fact that the diagonals are not equal, how did I convince ourselves of it? By choosing to draw a diagonal, by choosing to draw a parallelogram where the two diagonals were very different in length. So likewise, there's a way to draw a parallelogram so that these two angles, okay, I can make one of them as small as I like relative to the other one, okay. So in other words, you could say that I can make the ratios of these two angles as different as I want to. I can make one of them really small and the other one quite large in comparison to that. How can I do that? Here's how I can do that. So what I can do is, let's say this is a side. I start out with the side of the parallelogram, okay? And then what I do is, I start by drawing this angle, this angle. So this is a diagonal, not the other side. And I can make it as small as I wish, okay? So that's my diagonal, okay? And at any point, I can stop. I don't have to, I can extend it, like as far out as I wish to. But at any point, I can stop and I can join this. So what does that give me? It gives me this lower triangle. And now all I have to do is complete the upper triangle. Okay? How do I do that? Through here, I draw a line parallel to this. And through here, I draw a line parallel, or through here, I draw a line parallel to the base. So naturally, this is much smaller than that. Okay, I can make it even smaller. I can make, let's see. I can make this angle even smaller, as small as I like, really. And at any stage, I can join this and complete my parallelogram. Okay, so do they bisect the corner angles? No, they don't. So the answer to this question is a no. So what I would suggest you do is, so these are really the only things to look out for in a quadrilateral. So what I would suggest that you do is, in order to gain a deeper understanding of quadrilaterals, in order to be able to really feel quadrilaterals, draw pictures of quadrilaterals and then use this as a guideline to study their properties. Okay. Now, here's a question for the class. Let me first erase some of this. No, never mind. Never mind. No, that question that I had in mind would come later. Okay. So the next thing that we are going to do is we are going to closely study a rhombus. Okay, using these guidelines. Okay, so using these guidelines, we are going to investigate a rhombus and try and find, basically, we'll try and look for equality in these various line segments, in these various angles, and so on and so forth. So first, so what's a rhombus? How do you define a rhombus? Okay, so rhombus is a parallelogram. Okay, all of whose sides are the same. In your book, on this chapter, they say that a rhombus is a parallelogram such that, and the way to draw a rhombus is like this. This is just a rough picture. I'm going to put up a bigger picture up here. So in your book, the way it's defined is that a rhombus is a parallelogram such that a pair of its adjacent sides are the same. And from that, you can easily conclude that therefore, all four of its sides would have to be the same, because for a parallelogram, opposite sides are equal. Okay. So what we would do is, we would depart slightly from that definition. We'll just accept that a rhombus is a parallelogram, all four sides of which are equal. Okay. So that's the way to draw a rhombus. Okay, and another useful thing to remember what rhombus is. No, actually, no, I won't mention it now, but it'll come up as we are studying the rhombus. I was about to give out a property of rhombus, but we'll come across that property. So this is how a rhombus is to be drawn. So it looks like a diamond shape. Okay, the diamond shape from a deck of cards. So that's what it looks like. So now we will investigate into a rhombus. So first things first, let's look at the four sides. Are adjacent sides equal? Sure. Are opposite sides equal? Sure. In fact, all four sides are equal. So the answer is yes to all of these. By the way, let me tell you one thing. See, I'm jotting down these answers to this. I don't mean to tell you that you need to memorize these or anything like that. No. This is just a guideline for you to be drawing pictures and using this guideline to do your own investigation into these figures. Okay, so that must be clear. So this is not like theory that you need to memorize, not at all. Just the other way around. You need to learn to get used to these figures through this process of investigating, okay, into the various properties of this figure. Okay. Now about the four interior angles. Let me get rid of the diagonals for a second. So this is what we have, and we noted that the four sides of a rhombus are all equal. Now about the interior angles, are any of these equal? Sure, opposite angles are equal. Also, that also stems from the fact that you got to remember that a rhombus is a parallelogram. So all properties of parallelogram carry over in the case of a rhombus. Plus, the rhombus has a few special properties of its own, which we will see. So about the four interior angles, as you can tell, it's very easy to see that these two are the same and these two are equal. Okay. So now let's draw the diagonals. Are the diagonals equal? I'm asking you. Are the diagonals equal?
No, sir.
No, they're not. And again, as in the case of a parallelogram, I can make the difference between the diagonals as big as I like. I can choose one diagonal to be really small and the other diagonal to be relatively larger. Okay, so that would give me a rather flat rhombus. Something like this. Okay. So, are they equal? No. Do they bisect each other? Okay. Are these two the same? Are these two the same?
Sir.
Absolutely. They do bisect each other. So this is the same as this, and this is the same as this. Do they bisect each other at angles having special values?
Yes, sir.
Absolutely. And what is that value?
90 degrees.
90 degree, right angles. Absolutely. So these four angles are right angles. So it's a yes for this, and this is a yes, and the angle values are right angles. Do they bisect the corner angles? Just visually, like, you know, we are not trying to prove anything here, just visually. Do these get bisected? What does it appear like?
Yes, sir. They get bisected.
They do. Now, as we saw, for an arbitrary parallelogram, for a random parallelogram, that is not true. But for a rhombus, it is true. So in other words, what we can do is we can relabel these angles as follows. So if this is x, this is x, and if this is x, this is x, which also goes on to show that 2 times x is equal to 2 times x. The whole corner angle is equal to the whole corner angle, and additionally the diagonal also bisects these two. And if this is y, and these two are y as well. Okay, so now for this rhombus is another way of thinking about a rhombus. What do you notice here? You know, this diagram, let me do something. It's not drawn too accurately, so that's more like it. No. Okay, that's kind of, okay, that's a better diagram. Now, whenever you draw the two diagonals in a quadrilateral, what they do is they break up the quadrilateral into 4 triangles, correct? So notice that these 4 triangles, they are all right angles, number 1. Number 2, they are congruent. They're congruent right angle triangles, correct? So here's another way of thinking about a rhombus. You can think of a rhombus as being made up of 4 congruent right angle triangles glued together, okay, as this picture showed, okay. So you take 4 congruent right angle triangles, and then when you glue them together, you get a rhombus. So that's one way of thinking about a rhombus, okay. Okay. So the next thing that we'll do is we are going to look at a rectangle, and again put a rectangle under the scanner, okay, using our guidelines. You know, we are going to try and see, like, you know, what we can, you know, what we find out. We are going to investigate a rectangle. So first things first. So a rectangle, here's something to bear in mind, it is a parallelogram. Both rhombuses and rectangles are special cases of parallelograms, okay. So a rectangle is a parallelogram for which the corner angles are equal and each is equal to 90 degrees. So let's pause to think about this for a moment. A rhombus is a parallelogram with equal sides, and a rectangle is a parallelogram with equal angles. Now, obviously, if each interior angle has to be the same, since the sum of the interior angles is 360 degree, that would imply that each angle has to be a right angle. Okay, so that's what a rectangle is. But there's a reason why I emphasize this definition, okay? Because this will play a role in what's to come. So think of a rhombus, again, let me repeat. Think of a rhombus as a parallelogram with equal sides and a rectangle as a parallelogram with equal interior angles. And obviously that would mean that each interior angle is equal to 90 degree. So that's a rectangle. And what can we say about the four sides? Just as in the case of a parallelogram, the opposite sides are equal, but not the adjacent sides. They're not equal. They could be. Now, if the adjacent sides are equal as well, then what's the figure that we get? What happens to a rectangle if these two become equal as well?
It
Yes?
becomes a square.
Absolutely, absolutely becomes a square, which is a special rectangle. Okay. Okay, so we are done with this. Okay. So adjacent sides are not equal, but opposite sides are equal, as in the case of parallelograms. Now about the four interior angles, are any of these equal? Yeah, sure. They all are equal, and they're equal to a right angle. Now let's talk about the diagonals. Are they equal, the diagonals?
Yes, sir.
Sure, they're equal. By the way, here's something I wanted to pause, okay, and pause myself and mention. See, the properties that we are discovering through this investigative process, through this, like process of investigation, okay, so we are doing it just visually. We are not getting into proofs and what have you. But remember that each property that we discover can also be proved, and predominantly the proof would rely on congruence of triangles. And most of these proofs are pretty easy. You've probably seen many of them, okay? But today the whole idea is not to get into proofs. It's more like, drawing pictures and, like investigating to see where we see equality in line segments or in angles, okay? So that's the whole idea. Okay, so are the two diagonals equal? Sure, they are. Do they bisect each other?
Yes, sir.
Absolutely. It's kind of obvious because see, parallelograms, you already saw that for parallelograms, the angles bisect each other. So even here, you would expect for a rectangle, which is a special parallelogram, you would expect that the diagonals bisect each other. Now, here's the thing. When I drew a parallelogram, together with its diagonals, what I did was, I want to draw your attention to this notation. Okay, I denoted all four to be equal. Here, I couldn't do that because while this is equal to this and this is equal to this, the holes are different. This is not the same as this. So, so this piece is not the same as this piece. But here, since the two diagonals are equal, additionally, if they bisect each other, we would know that half of each of these diagonals are also equal. So I can use the same symbol to designate these four line segments, each of which is half the diagonal. Okay. So we are through with this. Do they bisect each other? Yes. Do they bisect each other at angles having special values?
No.
Sir.
No. Okay. So this can be anything. And again, if I like, I can draw a parallelogram where the difference between these two angles, I can make them, as different as I wish. How? Again, I would start by drawing not the rectangle, but rather the diagonals. So all I would do is in order to have my rectangle, all I need to do is draw two diagonals of equal length such that they crisscross at their mutual midpoints. So this has to be the midpoint for this, as well as, so I would take a second diagonal. So I just do this, and then I want to draw a second diagonal, but I want to make this angle really small, such that this becomes really big. So I can do that. Okay, so I made this really small in relation to that, okay, the other one. And now all I have to do is join the endpoints of these line segments, and I have my rectangle, okay. So this is similar to what I did for parallelograms, okay. So but there's one little distinction. So if you wish to draw a parallelogram starting with the diagonals, what you need to do is you need to draw two lines that bisect each other, but the two lines must be of unequal lengths to get a general parallelogram. Okay, they must be of unequal length. Then we have a parallelogram. But if you wish to generate a rectangle, then again you need two lines. If you wish to draw a rectangle starting with the diagonals, you need to draw two lines that again bisect each other, but this time these two lines must be of equal length. They must be of equal length. Okay. So let's see. This is a little too long.
Sir,
Sir, I think you're
Sir.
muted.
sir, I cannot hear your voice. Sir, I cannot hear your voice.
Sir, I cannot hear you.
Sir is unmuted.
Sir is telling to wait.
Can you hear me now? Hello, can you hear me?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
good. Yeah, the battery went dead. So, so anyhow, going back to what I was saying, the diagonals of a parallelogram versus the diagonals of a rectangle. Let me see how we are doing time-wise. Okay, we still got some time. So, the essential difference is that for a parallelogram, okay, what's the similarity? Similarity between the diagonals of a parallelogram and rectangle are that they bisect one another. The difference is they are of unequal lengths. Okay, so as I showed you, that there's an interesting way of drawing a parallelogram and therefore a rectangle, because a rectangle is a parallelogram. There's an interesting way of drawing it by starting out with the diagonals. Now, if you want your figure to look like a parallelogram, then you need to start with two bisecting line segments of unequal lengths, you get a parallelogram. If you start with two bisecting lengths that are of equal length, you get a rectangle. So, anyway, so going back to, so this whole discussion started with this point: do they bisect each other at angles having special values? The answer is a no. And here's what I wish to do, just to stretch this whole idea of generating these quadrilaterals by starting out with the diagonals, just to stretch that idea a little bit. Here's something interesting for you to consider, okay? So let's imagine that these two markers, they represent these two line segments using which I'll be drawing the, drawing a, which represent the diagonals of a rectangle because they are of equal length. So I'm going to get rectangles. So if I place one of them at a fixed position and imagine I take the other one so that they bisect, okay? So these four lengths are the same. And then, and this is something you would try at home, a couple of pencils would work better, I think, than these, thick markers. And now all you have to do is you have to kind of visualize that these four tips and the bottoms of the marker would be the four corners of your rectangle. Then by rotating this marker around, you can generate rectangles of all possible shapes. Not sizes. Size pertains to, like how magnified you make a rectangle. But shapes, yes, all shapes. So when you have something like this, you will have a rectangle whose width is very small compared to its length. And then as you open up this angle, the width and the length becomes of comparable sizes. And then, of course, when they are at right angles to each other, you get what do you get? What does this figure look like? Imagine joining the tops and the bottoms. Square. Perfect. Yes. Okay, so this is just a like little thing that I thought I'll show you. And of course, if you take two pencils, try this with pencil. If you take two pencils of unequal length and you line them up so that like the point at which they meet would be the midpoints of both, and then try rotating, hold one pencil fixed and try rotating the other one, okay? And then that will generate for you parallelograms of all possible shapes really, okay? Okay, so just a second. So we are through with this. Do they bisect each other at angles having special values? No. Do they bisect the corner angles? What do you think?
No, sir.
They don't. And again, I can make the discrepancy between this angle and this angle as big as I like. How? By first drawing the base, and then first I'm going to attempt to draw this triangle. Accepting that, I'll make it somewhat like this. I'll make it a flattened version of this, and then I'll complete my rectangle. I'll make sure that this is a right angle. Okay, so I have this lower triangle in place, and then all I have to do is complete the rectangle. So how do I do that? Through here I draw another perpendicular to the base equal in size with this, and then I join this. So notice here, this figure highlights the fact that that these two angles can be rather different, okay, as different from one another as we wish in terms of ratio. Like if you take the ratio of the smaller to the bigger, you can make the ratio as small as you like. So the answer to this is also a no. Okay. So now here's something to bear in mind. rhombus versus rectangle. Here's something I wish to point out to you. When we are discussing rhombuses, I mentioned that one way of thinking about a rhombus is that a rhombus is nothing but 4 congruent right angle triangles glued together, right? You remember that part? I'm not hearing much responses. You need to be more responsive and participate more in the class, right? Does everyone agree with that?
Yes, sir.
Yes, right? Now, likewise, what can you say about a rectangle? Notice that in a rectangle comprises of 4 triangles, and this, these are congruent, and they are isosceles, okay? And again, this triangle and this triangle are also congruent, and they are isosceles triangle. That follows from the equality of these sides, okay? They're different. I mean, this is not the same as, this is not, these two are not congruent, but these are and these are. So one way of thinking about a rectangle is that you have a pair of isosceles triangle. This is the first pair and this is the other pair, and then they are glued together. That gives you a rectangle. And again, for a rhombus, for a reason, I'm reminding you of this. For a rhombus, we have 4 identical right angle triangles, 4 congruent right angle triangles. You glue them together, you get a rhombus. So now, what we are going to do as the next step would be to study a square, which is the most symmetric figure of all of them. Okay. So before we do that, here's something I want you to kind of think about. And take notes on this one. I would suggest that you do. By the way, you all have seen set theory, right? A little bit of that, unions and intersections and all that good stuff, right? Okay.
Yes, sir.
So we are going to use a little bit of set theory to try and understand the interrelationship between these figures. You'll see how it goes. So first things first. First, I wish to write this down. I wish to write some definitions down. So a parallelogram means both pairs of opposite sides are parallel. A rectangle is a parallelogram. Oh, yeah, parallelogram. Let me write it like this. With equal angles, and by angles I obviously mean the interior angles, and each is equal to 90. And a rhombus is a parallelogram with equal sides. Okay? All right. Now, what we are going to do is, imagine that this is a set that consists of rectangles of all possible sizes and shapes. Okay, all possible sizes and shapes. So this is the set of all rectangles. And let's say we have the set of all rhombuses. All possible sizes and shapes. So what is the characteristic of elements belong to this set? What distinguishes them? They are parallelograms with equal angles. What's the characteristic of elements that belong to this set? They are parallelograms with equal sides. Therefore, based on what you have learned about the intersection of two sets, what can you say about this intersection? What's the characteristic of figures that, lie in the intersection? Absolutely. So what lies in the intersection would have quadrilaterals that belong to this intersection would fulfill this property as well as this property. So they are parallelograms with equal angles and equal sides. It's a square. Okay. So that's the interrelationship between rhombuses, rectangles, and squares. Okay. So as you can see, just by focusing on the set of rectangles, squares are a special class of rectangles. Likewise, squares are a special class of rhombuses. Okay. And now just to, complete this picture, we draw a big box around it, and this, we call this set the set of all parallelograms. Okay. So that's the set of, so I should write here, set of all rectangles, set of all rhombuses, and these are the squares. I'm not writing set of all parallelograms. Okay, so this is how, so this is an important Venn diagram. Okay, because it shows you exactly how these, like these figures that are so common in geometry, they're like central to geometry, how they are all, like interlinked. Okay, we are nearly through with the time for the class, but if I can have another 5 minutes, just one interesting thing that I would like to show you. Okay, any questions on this? Any questions, any remarks? Yes, okay. All right, so it's clear, I take it. It's clear to everyone?
Yes, sir.
Yes.
Huh?
Yes, sir.
Yes.
Yes, sir.
Okay. Okay, now, see, remember that guideline that I wrote down at the beginning, using which, we investigated the, like the various equalities and, like that that are found within a parallelogram, a rectangle, and a rhombus. So you could do the same with a square. You could do the same with the square. So I'm not going to repeat that, but as far as the square is concerned, here's something interesting that I wish to point out to you, okay? Based on this interrelationship, okay? Now, if you recall, so let's see, let's draw a square. So here's a square. Okay. Now a square. Okay, let me on the side also pull up the diagrams for a rhombus and a rectangle. So we are going to make an interesting deduction, okay, about the nature of these four triangles. So how do we do that? Here's how we do it. So for a rhombus, we know that these four triangles are right angled, correct? And we know that squares are special rhombuses. Therefore, we know that these are right angled triangles. Point number one. Point number two, for a rectangle, we know that all four triangles, all four of these are isosceles triangles. Okay, maybe this is not congruent to this, but that doesn't change the fact that all four are isosceles. So what can you say about these four triangles? They also have to be isosceles. Why? Because squares are special rectangles. So these four triangles would be right angled as well as they have to be isosceles. So they are right isosceles triangles. Have you come across this triangle? Right isosceles triangle, right angle isosceles triangle. Yes? Yes. So what do these triangles look like? 45, 45. So each of these angles are 45 degrees. So that's a way of thinking about a square. A square is comprised of four identical right isosceles triangles glued together. Okay, so that completes the picture. So a rhombus comprises of four identical, as in congruent, right angle triangles glued together. a rectangle consists of 4 isosceles triangles, and the opposite ones being congruent, and a square is nothing but 4, right isosceles triangle glued together. So that kind of finishes the picture. Okay, so that was just an overview of quadrilaterals. So, so we'll end the class here, but please, what I would like all of you to do is use that guideline, okay, to test these figures, like do your own inquiry. So today, it was a guided inquiry, if you will. I mean, I helped you through, the investigation. You should do that yourself, because if you do that sufficiently many times, you'll realize that you are getting a very good handle on these figures. And number 2, this is a very important diagram because it tells you how these various, like these 4 central figures, these 4 figures that are central to geometry, parallelogram, rectangles, rhombuses, and squares, how they are interrelated. Okay. And then here in the last step, we studied their interrelation in terms of these 4 components that they get broken into once you draw the 2 diagonals. Okay, so that kind of finishes the picture. Okay, so next class, I suppose we'll be getting into, like construction of quadrilaterals. And I wish all of you a very happy weekend, and I'll be seeing you next Saturday.